So is it one-sided or two-sided hypothesis? Alternative hypothesis. So to answer that, we can go back to the researcher's original question or its original interest. So it says we want to know, or they want to know, if the male and female um, geckos differ significantly. So differs, right? So they are not interested in whether one is less than other or greater than other. So only thing we are interested in is, do they differ? So mean for male, is that different from mean for female? That's what we are interested in. Or you can also write it as mu male minus mu female is not equal to 0. So you know right away that it's a two-sided hypothesis. Thing to note in this case is that we should never be considering sample findings in null and alternative hypothesis, because hypothesis is everything about parameter population, not sample findings. Now let's give it a shot for this one. Pause the video and try to answer it. Do chicks fed high lysine diet in group 2 gain more weight than chicks fed normal corn in group 1? So we have two different groups, independent. So we know that this is two sample T test. Hypothesis null, alternative is given to us, mean, and they have performed everything. So we have to interpret based on that, based on this p-value. So the answer here is that yes, the p-value we have, the small p-value we have the strong evidence that mean weight gain for chicks fed a high lysine diet is greater than chicks fed the normal corn. So basically our p-value we are going to compare with the alpha level significance, which is on most of the time 0.05 for 95%, and since this is less than that, we reject null. So we are going to reject null hypothesis, and we are going to that there is no difference, and we favor the alternative hypothesis, and our alternative says that lysine is greater for one of the group. That's so the high lysine diet group has, that is mu2 is greater, and if it is greater, then we are going to get that difference as less than 0. That's why this is an answer. This would have been the answer if the p-value would have been greater than this 0.05. In that case, we would have failed to reject the null hypothesis, and in other words, we would have not accepted, but there would have been a possibility to end up in null hypothesis. So two-sample T confidence interval is the same thing. Concept remains same, that it's around the mean and with some margin of error. It's just that instead of all those z, now we are looking for t values around the mean value. So minus t, margin of error, all the concept remains same. Calculation differs because now we have two samples, so that's why we'll be looking at two different parameter or statistic here to estimate parameter. So that's just the formula. Now we are going to see the implication of that. So in this question, how does pesticides help seeding growth? Seeds are randomly assigned to be planted in plot with soil treated with pesticide or in pot with untreated soil. So two different samples right away we know. This is one, this is second one, independent. So that's why two sample T test. Seeding growth in millimeter is recorded. That's our outcome that we are recording after 2 weeks. This doesn't matter. So tree groups treatment, control, soil treated with pesticide is treatment, untreated is control. We have been given the data. Based on that, we can calculate the sample size because we can just simply count it, or maybe they have been given in question step. We know how to calculate the mean for each of these groups. So mean x1 would be mean for treatment group, that's nothing but this one, and x1 x2 would be this one, this would be s1, this would be s2. So because this is first sample, second sample, whatever you decide. Now for confidence interval level, we have seen that margin of error is nothing but this particular portion, and since it's around the mean, we subtract these two different means and add this margin, add or subtract margin of error around that mean difference. We know how to calculate degrees of freedom based on the same data, and once we know that, we just have to substitute that. Only thing we have to calculate here is, or find here, is t value, and we can do that by making use of two pieces of information. One is degrees of freedom, and another is in this case confidence interval. On most of the time, if it is unspecified, you can go for 95% confidence interval. So using table C, this is the shorter version. First thing is go throughout the row and locate the degrees of freedom. If it is 37, go for the lower closest boundary, that's 30, and locate the corresponding 95% confidence, that's most commonly used, and that's the criticality. That means you know everything in this formula, and you should be able to get two values based on plus or minus margin of error, and that's nothing but going to be your 95% confidence interval. So that was by hand calculation, but most of the time we end up using software to proceed with this Twosample T test. Either you can go for Excel, that will spit you degrees of freedom for you and critical T value and margin of error, and so you can get the confidence interval. Similarly, SPSS could also give you degrees of freedom and 95% confidence interval with lower and upper boundaries. So let's give it a shot for this question. In this case, it's similar to what we have covered earlier. It's like interpretation question. So pause the video and give it a shot. So in this question, null alternative hypothesis is stated. Everything, all the test has been performed, and they have ultimately calculated 95% confidence interval. So here is the appropriate testing for interpretation of confidence interval. So if this is your result, lower boundary, which of these following is true? So answer is no, the evidence is not sufficient, and we are going to look at why. So whenever we define a confidence interval, we say that we are 99% confidence, as in this case we are looking at 99%. We are 99% confident that whatever that we are looking at in this case, difference in mean may be somewhere ranging from negative 76 to 3. So it could be negative 76, negative 10, or it could also be 0. That's critically important. Or it could be 1, it could be 2, it could be 3.66, something like that. So it could have any range for this mean difference, mu1 minus mu2. So our interest is that to check if our hypothesis is regarding the difference. If it is going to include 0, that means our null hypothesis is going to be true, right? So we will fail to reject the null hypothesis in this case just because the interval includes 0. Why 0 is important? Because we are looking at difference. If mu1 equal to mu2, then it's going to be 0, right? So for example, mu1 is, let's say, I don't know, 5, and mu2 is 5. 5 minus 5 is 0. That means there is no difference, right? So that is why we are interested in 0, interested in checking whether the 0 lies within these interval, that is the lower boundary and upper boundary. If it lies, we fail to reject the null. So we say that no, the evidence is not significant at 1%. Why we say that 1%? Because we are looking at 99% confidence interval. So our significance level becomes the remaining 1% out of 100 to conclude that the lysine diet is more effective. So that's how you should be. And the answer is not yes, because if it would have been yes, then the zero would not be in the interval. So you might have the intervals something like positive and 76 to, I don't know, 33, or actually it would be 76 to 83. The zero is not included. It could have been yes or statistical significant, or it could also be negative 76 to negative 89. It doesn't matter as long as zero is not included in this interval. That would be statistically significant, but that's not the case with this question. Now, robustness. So this will be the theoretical part. Robustness, we know that t-test robustness depends on the sample size. The distribution has to be similar at least for two different groups, if not exactly normal. How big is sample size good enough? Then there are some rules. So both n1 and n2 has to be 40 or more. So if you are looking at treatment group and control group, so participants in treatment group and participants in control group has to have total more than or equal to 40 to be considered this two sample test to be robust. And you can definitely plot the data using histogram, dot plots, stem plots, normal quantile to check the normality if required. Avoid the pooled two sample T procedure. So there are two different versions of two sample T procedures, and we are going to briefly go over this. One assuming the equal variance pooled, and one not assuming equal variance. And there are like several tests that we could do, Levin's test, hypothesis testing, and so on. That will not be part of this course, but I just wanted to briefly touch on this, that there could be there are two different versions, one with assuming equal variance and not assuming equal variance. The pooled equal variance two sample t-test has degrees of freedom n1 plus n2 minus 2. It is minus 2 because we are using two different pieces of information here. However, assuming equal variance is hard to check. That's why it's better to go for unequal variance, because that's just simply safer. So it is better to use option of unequal variances when comparing two population, because the unequal variance option is valid whether the two population variance are equal or not. It's just the safer option, right? That's why we should go for that. Now the review of this entire T procedure. So I know there are like several confusions, so that's why I think this is pretty useful. So overall T procedures, we know that there are one sample T procedure, match T procedure, and two sample T procedure. One sample T procedure summarizes the mean standard deviation, and we don't know about the sigma and mu as well. So we infer about the mu. So just like maybe null is mu is equal to some values, or simply 0, or 12, or alternative will be mu greater than 12, something like that, based on one sample, when the sigma is not known. If you know the sigma, then it would be Z test or Z procedure. Match pair T procedures, you know, these are the matched individuals. So either they are matched on some genetic or some variables, or these are pre-post tests. So same individuals having two different data points, two different data at two different time points. So one after treatment and one before treatment, but these are based on same individuals, so these are matched pairs. Or it could be one individual and two treatments, and the same individuals receiving one treatment at one particular time, and 10 weeks later they are receiving the other treatment. But since these are the same individuals receiving treatments, they serve as their own matched pair. So we use matched pair. So these are the three different scenarios, and you can read about this in detail from previous chapter. So we looked at x difference and mean difference. So if it is pre-post, we have calculated some x value for pre, x value for post, and then we have just subtracted that and calculated the x difference. And we did this similarly for all the individuals that you have in data points. So 1n, and this is still x 2n, and you are going to get difference for x1n minus x2n. So all the individuals. And once you know this x difference variable, based on that data you calculate a mean difference and sigma difference. That's nothing but the match pair t-test. Two-sample t-test is whenever the two different samples are mentioned and those two different samples are independent. So we estimate these parameters based on these samples, and we infer about whether the mean difference is equal to 0 or not, or if it is less than or it is greater than, depending on the type of your interest. So these are some kind of questions which are critical from this chapter, more theoretical rather than the calculation based. So I would like to emphasize on these questions. So let's pause the video and maybe you want to give it a try. Which type of t-inference procedure can be used for each of these scenarios? And you have to choose from options one sample, match pairs, or two sample t-test. So for the first scenario, is blood pressure altered by use of an oral contraceptive? Comparing a sample of women not using an oral contraceptive, that's one sample, with sample of women taking oral contraceptive. So right away you know these are two samples, so we are going to use two sample t-test. So answer would be C, right? Two samples for the first scenario. For this second scenario, average cholesterol level in general adult population is 175 milligram per dl. Take a sample. So we are taking a sample of adult with high cholesterol parent. Is the mean cholesterol level higher in this group? So we know it's one sample. We are interested in that particular sample. So it's going to be one sample t-test. So that's why the answer is A, one sample t-test. Let's look at the third question. It says, does a bread lose vitamin with storage? Take a sample of bread loaves and compare vitamin content right after baking and again after 3 days later. So you are looking at the same sample of bread loaves, but one right after baking and another is 3 days later. So at two different time points. That's why it's going to be matched pair t-test. So answer is B, matched pair. The last one, does the bread lose vitamin with storage? Take a sample of bread. So take one sample of bread loaves just baked and a sample of bread loaves stored for 3 days. So there we cannot say anything about we cannot say that these samples are dependent. So basically these are independent, and we try to compare the vitamin contents, and if these are independent samples then we know that we should go for two-sample T test, and that's why the answer is C. So these are the some critically important question that you should be focusing on.